Hi guys, welcome to Virtual Me. Someday maybe this will be a hologram, but right now you just have me standing by the whiteboard in front of the computer. So, what do we know so far? So far, we know that the slope of the secant line, which is f of x2 minus f of x1 over x2 minus x1 is equal to an average rate of change or average velocity. You can't see that, can you? Hold on just a minute. Let's make it so you can see what I just wrote. There we go. Okay, average rate of change or average velocity. And we know that the slope of the tangent line is the limit as h approaches 0 of f of x plus h minus f of x all over h, and that this is equal to an instantaneous rate of change. Okay? Or again, if we're talking about velocity, it's the instantaneous velocity. And again, what did that look like? It looked like here's a curve, here's the point where we want the slope of the tangent line, and if we took a second point that was a little further away, and we called it x sub 0 plus h, and we looked at the slope of that secant line, and then we took another point closer in, and we looked at the slope of that secant line, that as h got closer to 0, these slopes of secant lines approached our slope of the tangent line. Well, and you remember one other thing. We said if we use this formula at a specific point, so I'm going to come over here for a minute, you can still see. So if we had, let's go over a little more, you can see this. If we had f of x equal to x squared, and I wanted the slope of the tangent line at x equals 1, we knew I could take the limit as h approaches 0, f of 1 plus h minus f of 1 all over h, which was equal to the limit as h approaches 0, 1 plus h squared minus 1 squared over h, which was equal to the limit as h approaches 0, 1 plus 2h plus h squared minus 1 over h. The 1's canceled. I factored out an h. I canceled the h's, and the limit was 2, right? So this was the slope of the tangent line at x equals 2. Okay? Then we said, well, if we had to do that at a whole bunch of points, I could just take the general form of m tan. And that's the limit as h approaches 0 of f of x plus h. I'm not going to write that. We're just using this formula right here. So my function is x squared. So what do I have? X plus h squared minus x squared over h. What's that equal to? The limit as h approaches 0, x squared plus 2xh plus h squared minus x squared all over h. Again, things cancel. They'll always cancel. Oops, got to stay out of the way here. Factor out an h. I have the limit as h approaches 0 of h times 2x plus h over h. These cancel, and my limit is 2x. And that's the formula that lets me find the slope of the tangent line at any x. That's all review. Well, it turns out that this limit is so important that we call it the derivative. So what we're going to do now is we're going to give this limit here a new name, okay? And now we're going to say that this right here, I'm going to erase this now. And we're saying this limit right here is so important that it has a new name. It's equal to the derivative. And the notation is f prime of x. You read that as f prime of x. And again, what is it? It's the slope of the tangent line. It's this limit. It's the instantaneous rate of change. They're all the same thing. We haven't learned anything new. We just gave it a new name. Okay? So, other notation, df dx. We just read that, df dx. It means the derivative of f with respect to x. That just means x is the variable. That's all it means. So now I can say find the derivative of f of x equals 2x squared plus 3x. And what does that mean? It means find the limit as h approaches 0 of 2x plus h squared plus 3x plus h, that's f of x plus h, minus 2x squared plus 3x, all over h, and carry that out. If you look in your notes, okay, this is solved out in the notes. Okay, so look there to find the rest of that problem.